Apache Spark is a powerful framework which is being heavily used in the industry for real-time analytics and machine learning purposes. So I, Kisle, on behalf of Edureka, welcome you all to this session on PySpark tutorial. So before I proceed with this session, let's have a quick look at the topics which we'll be covering today. So starting off by explaining what exactly is PySpark and how it works. Moving ahead, we'll find out the various advantages provided by PySpark. Then I'll be showing you how to install PySpark in your systems. Once we are done with the installation, I will talk about the fundamental concepts of PySpark, like the Spark context, DataFrames, MLlib, RDDs, and much more. And finally, I'll close off this session with a demo in which I'll show you how to implement PySpark to solve real-life use cases. So without any further ado, let's quickly embark on our journey to PySpark. Now before I start off with PySpark, let me first brief you about the PySpark ecosystem. As you can see from the diagram, the Spark ecosystem is composed of various components like Spark SQL, Spark Streaming, MLlib, GraphX, and the core API component. The Spark SQL component is used to leverage the power of declarative queries and optimize storage by executing SQL-like queries on Spark data, which is presented in RDDs and other external sources. Spark Streaming component allows developers to perform batch processing and streaming of data with ease in the same application. The machine learning library eases the development and deployment of scalable machine learning pipelines. GraphX component lets the data scientists work with graph and non-graph sources to achieve flexibility and resilience in graph construction and transformations. And finally, the Spark core component. It is the most vital component of Spark ecosystem, which is responsible for basic input-output functions, scheduling, and monitoring. The entire Spark ecosystem is built on top of this core execution engine, which has extensible APIs in different languages like Scala, Python, R, and Java. And in today's session, I will specifically discuss about the Spark API in Python programming languages, which is more popularly known as the PySpark. Now you might be wondering why PySpark? Well, to get a better insight, let me give you a brief into PySpark. Now, as we already know, PySpark is the collaboration of two powerful technologies, which are Spark, which is an open source clustering computing framework built around speed, ease of use, and streaming analytics. And the other one is Python, of course. Python, which is a general purpose high-level programming language. It provides a wide range of libraries and is majorly used for machine learning and real-time analytics. Now, which gives us PySpark, which is a Python API for Spark that lets you harness the simplicity of Python and the power of Apache Spark in order to tame big data. PySpark also lets you use the RDDs and come with the default integration of Py4j library. We'll learn about RDDs later in this video. Now that you know what is PySpark, let's now see the advantages of using Spark with Python. As we all know, Python itself is very simple and easy. So when Spark is written in Python, it makes Apache Spark quite easy to learn and use. Moreover, it's a dynamically typed language, which means RDDs can hold objects of multiple data types. Not only this, it also makes the API simple and comprehensive. And talking about the readability of code, maintenance and familiarity with the Python API for Apache Spark is far better than other programming languages. Python also provides various options for visualization, which is not possible using Scala or Java. Moreover, you can conveniently call R directly from Python. On top of this, Python comes with a wide range of libraries like NumPy, Pandas, Sktlin, Seaborn, Matplotlib, and these library aids in data analysis and also provide mature and time-tested statistics. With all these features, you can effortlessly program in PySpark in case you get stuck somewhere or have a doubt. There is a huge PySpark community out there whom you can reach out and put your query, and that is very active. So I will make good use of this opportunity to show you how to install PySpark in your system. Now here I'm using a Red Hat Linux-based CentOS system. The same steps can be applied for using Linux systems as well. So in order to install PySpark, first make sure that you have Hadoop installed in your system. So if you want to know more about how to install Hadoop, please check out our Hadoop playlist on YouTube, or you can check out our blog on Edureka website. Now first of all, you need to go to the Apache Spark official website, which is spark.apache.org. In the download section, you can download the latest version of Spark release, which supports the latest version of Hadoop or Hadoop version 2.7 or above. Now, once you have downloaded it, all you need to do is extract it, or rather say untar the file contents. And after that, you need to put in the path where the Spark is installed in the bash rc file. Now, you also need to install pip and Jupyter Notebook using the pip command and make sure that the version of pip is 10 or above. So as you can see here, this is what our bash RC file looks like. Here you can see that we have put in the path for Hadoop, Spark, and as well as PySpark driver Python, which is the Jupyter notebook. What it'll do is that the moment you run the PySpark shell, it will automatically open a Jupyter notebook for you. Now, I find Jupyter Notebook very easy to work with rather than the shell. It's a personal choice. Now that we are done with the installation part, let's now dive deeper into PySpark and learn few of its fundamentals, which you need to know in order to work with PySpark. Now this timeline shows the various topics which we will be covering under the PySpark fundamentals. So let's start off with the very first topic in our list, that is the Spark context. The Spark context is the heart of any Spark application. It sets up internal services and establishes a connection to a Spark execution environment. Through a Spark context object, you can create RDDs, accumulators, and broadcast variable, access Spark services, run jobs, and much more. The Spark context allows the Spark driver application to access the cluster through a resource manager, which can be Yarn or Spark's cluster manager. The driver program then runs the operations inside the executors on the worker nodes, and Spark context uses the Py4j to launch a JVM, which in turn creates a Java Spark context. Now there are various parameters which can be used with a Spark context object, like the master, app name, Spark home, the PyFiles, the environment in which it's set, the batch size, serializer, configuration gateway, and much more. Among these parameters, the master and app name are the most commonly used. Now to give you a basic insight on how a Spark program works, I have listed down its basic lifecycle phases. The typical lifecycle of a Spark program includes creating RDDs from external data sources or parallelize a collection in your driver program. Then we have the lazy transformation. Lazily transforming the base RDDs into new RDDs using transformation, then caching few of those RDDs for future reuse, and finally performing action to execute parallel computation and to produce the results. The next topic in our list is RDD, and I'm sure people who have already worked with Spark are familiar with this term. But for people who are new to it, let me just explain it. Now, RDD stands for Resilient Distributed Dataset. It is considered to be the building block of any Spark application. The reason behind this is these elements run and operate on multiple nodes to do parallel processing on a cluster. And once you create a RDD, it becomes immutable. And by immutable, I mean that it is an object whose state cannot be modified after it is created. But we can transform its values by applying certain transformation. They have good fault tolerance ability and can automatically recover from almost any failures. This adds an added advantage. Now to achieve a certain task, multiple operations can be applied on these RDDs, which are categorized in two ways. The first is the transformation and the second one is the actions. Now transformations are the operations which are applied on an RDD to create a new RDD. Now these transformations work on the principle of lazy evaluation. And transformations are lazy in nature, meaning when we call some operation in RDD, it does not execute immediately. Spark maintains the record of the operations it is being called through with the help of dialectic acyclic graphs, which is also known as DAGs. And since the transformations are lazy in nature, so when we execute operation anytime by calling an action on the data, the lazy evaluation data is not loaded until it's necessary, and the moment we call out the action, all the computations are performed parallelly to give you the desired output. Now a few important transformations are the map, flat map, filter, distinct, reduce by key, map partition, sort by. Actions are the operations which are applied on an RDD to instruct Apache Spark to apply computation and pass the result back to the driver. Few of these actions include collect, the collect as map, reduce, take, first. Now let me implement few of these for your better understanding. So first of all, let me show you the bash RC file which I was talking about. So here you can see in the bash RC file, we provide the path for all the frameworks which we have installed in the system. So for example, you can see here we have installed Hadoop. The moment we install and unzip it, or rather say untar it, I have shifted all my frameworks to one particular location. As you can see, it's the USR, the user, and inside this we have the library, and inside that I have installed the Hadoop and also the Spark. Now, as you can see here, we have two lines. I'll highlight this one for you. The PySpark driver Python, which is the Jupyter, and we have given it as a notebook. The option available as notebook. What it'll do is at the moment I start Spark, it will automatically redirect me to the Jupyter notebook. So let me just rename this notebook as RDD tutorial. So let's get started. So here, to load any file into an RDD, suppose I'm loading a text file, you need to use the SC, which is a Spark context, sc.text file, and you need to provide the path of the data which you are going to load. So one thing to keep in mind is that the default path which the RDD takes or the Jupyter Notebook takes is the HDFS path. So in order to use the local file system, you need to mention the file, colon, and double forward slashes. Now once our sample data is inside the RDD, now to have a look at it, we need to invoke using it the action. So let's go ahead and take a look at the first 5 objects, or I'd rather say the first 5 elements of this particular RDD. Now the sample data I have taken here is about blockchain. As you can see, we have 1, 2, 3, 4, and 5 elements here. Suppose I need to convert all the data into a lowercase and split it according to word by word. So for that, I'll create a function, and in that function, I'll pass on this RDD. So I'm creating, as you can see here, I'm creating RDD1, that is a new RDD, and using the map function, or rather say the transformation, and passing on the function which I just created to lower and to split it. So if we have a look at the output of RDD1, so you can see here, all the words are in the lower case and all of them are separated with the help of a space bar. Now there's another transformation which is known as the flat map to give you a flattened output, and I'm passing the same function which I created earlier. So let's go ahead and have a look at the output for this one. So as you can see here, we got the first 5 elements, which are the same one as we got here, the contracts, transactions, and the records. So just one thing to keep in mind is that the flat map is a transformation, whereas take is the action. Now, as you can see that contents of the sample data contains stop words. So if I want to remove all the stop words, all I need to do is start and create a list of stop words in which I have mentioned here. As you can see, we have a, all, the, as, is, and. Now these are not all the stop words, so I've chosen only a few of them just to show you what exactly the output will be. And now we are using here the filter transformation. And with the help of lambda function, in which we have x specified as x not in stop words. And we have created another RDD, which is RDD3, which will take the input from RDD2. So let's go ahead and see whether the and the are removed or not. So as you can see, contracts, transaction, records of them. If you look at the output 5, we have contracts, transaction, and the. And the are not in this list. Now suppose I want to group the data according to the first 3 characters of any element. So for that, I'll use the group by and I'll use the lambda function again. So let's have a look at the output. So you can see we have EDG and edges. So the first 3 letters of both words are same. Similarly, we can find it using the first 2 letters also. Let me just change it to 2. So you can see we have GU and GUID, which is the guide. Now these are the basic transformations and actions. But suppose I want to find out the sum of the first 1,000 numbers, or rather say first 10,000 numbers. All I need to do is initialize another RDD, which is the num underscore RDD, and we use the sc.parallelize. And the range we have given is 1 to 10,000. And we'll use the reduce action here to see the output. As you can see here, we have the sum of the numbers ranging from 1 to 10,000. Now, this was all about RDD. Now, next topic that we have on our list is broadcasts and accumulators. Now, in Spark, we perform parallel processing through the help of shared variables. Or when the driver sends any task to the executor present on the cluster, a copy of the shared variable is also sent to each node of the cluster, thus maintaining high availability and fault tolerance. Now, this is done in order to accomplish the task. And Apache Spark supports 2 types of shared variables. One of them is broadcast and the other one is the accumulator. Now, broadcast variables are used to save the copy of data on all the nodes in a cluster, whereas the accumulator is the variable that is used for aggregating the incoming information via different associative and commutative operations. Now, moving on to our next topic, which is Spark configuration. Now, Spark configuration class provides a set of configurations and parameters that are needed to execute a Spark application on the local system or any cluster. Now, when you use Spark configuration object to set the values to these parameters, they automatically take priority over the system properties. Now, this class contains various getters and setter methods Now some of which are set method, which is used to set a configuration property. We have the set master, which is used for setting the master URL. We have the set app name, which is used to set an application name. And we have the get method to retrieve a configuration value of a key. And finally, we have set Spark home, which is used for setting the Spark installation path on worker nodes. Now coming to the next topic on our list, which is the Spark files. The Spark file class contains only the class methods so that the user cannot create any Spark files instance. Now this helps in resolving the path of the files that are added using the Spark context add file method. The class Spark files contain two class methods, which are the get method and the get root directory method. Now the get is used to retrieve the absolute path of a file added through Spark context.add file, and the get root directory is used to retrieve the root directory that contains the files that are added through the Spark context.add file. Now these are small topics, and the next topic that we'll covering in our list are the data frames. Now data frames in Apache Spark is a distributed collection of rows under named columns, which is similar to the relational database tables or Excel sheets. It also shares common attributes with the RDDs. Few characteristics of data frames are immutable in nature. That is the same as you can create a data frame but you cannot change it. It allows lazy evaluation, that is the task not executed unless and until an action is triggered. And moreover, data frames are distributed in nature, which are designed for processing large collection of structured or semi-structured data. It can be created using different data formats, like loading the data from source files such as JSON or CSV, or you can load it from an existing RDD. You can use databases like Hive, Cassandra, you can use Parquet files, you can use CSV, XML files. There are many sources through which you can create a particular RDD. Now let me show you how to create a data frame in PySpark and perform various actions and transformations on it. So let's continue this in the same notebook which we have here. Now here we have taken the NYC flight data, and I'm creating a data frame which is the NYC flights underscore DF. Now to load the data, we are using the spark.read.csv method. I need to provide the path, which is the local path. By default, it takes the SDFS, same as RDD. And one thing to note down here is that I've provided two parameters extra here, which is the info schema and the header. If we do not provide this as true, or we skip it, what will happen is that if your dataset contains the name of the columns on the first row, it will take those as data as well. It will not infer the schema. Now once we have loaded the data in our data frame, we need to use the show action to have a look at the output. So as you can see here, we have the output, which is exactly, it gives us the top 20 rows of the particular data set. We have the year, month, day, departure time, departure delay, arrival time, arrival delay, and so many more attributes. Now to print the schema of the particular data frame, you need the transformation, or as say the action of print schema. So let's have a look at the schema. As you can see here, we have year, which is integer, month integer, almost half of them are integer. We have the carrier as string, the tail number as string, we have the origin string, destination string, and so on. Now suppose I want to know how many records are there in my database or the data frame, I'd rather say. So you need the count function for this one, and it will provide you with the results. So as you can see here, we have 3.3 million records here, 3,036,776 to be exact. Now suppose I want to have a look at the flight name, the origin, and the destination of just these three columns for the particular data frame. We need to use the select option. So as you can see here, we have the top 20 rows. Now what we saw was the select query on this particular data frame. But if I want to see, or rather I want to check the summary of any particular column, suppose I want to check what is the lowest count or the highest count in the particular distance column, I need to use the describe function here. So I'll show you what the summary looks like. So the distance, the count is the number of rows, total number of rows. We have the mean, the standard deviation, we have the minimum value, which is 17, and the maximum value, which is 4,983. Now this gives you a summary of the particular column if you want to. Now that we know that the minimum distance is 17, let's go ahead and filter out our data using the filter function in which the distance is 17. So you can see here we have one data in which in the 2013 year, the minimum distance here is 17. Now similarly, suppose I want to have a look at the flights which are originating from EWR. Similarly, we'll use the filter function here as well. Now there another clause here, which is the where clause. It is also used for filtering. Now suppose I want to have a look at the flight data and filter it out to see if the day at which the flight took off was the second of any month, suppose. So here instead of filter we can also use a where clause, which will give us the same output. Now we can also pass on multiple parameters and rather say the multiple conditions. So suppose I want the day of the flight should be 7th and the origin should be JFK and the arrival delay should be less than 0. I mean, that is for none of the postponed flights. So just to have a look at these numbers, we'll use the where clause and separate all the conditions using the and symbol. So as you can see here, all the data, the day is 7, the origin is JFK, and the arrival delay is less than 0. Now these were the basic transformations and actions on a particular data frame. Now one thing we can also do is create a temporary table for SQL queries. If someone is not good or is not acquainted to all these transformation and action and would rather use SQL queries on the data, they can use this register.temp table to create a table for their particular data frame. What it'll do is convert the NYC flights underscore DF data frame into a NYC underscore flight table, which can be used later and SQL queries can be performed on this particular table. So you remember in the beginning we used the NYC flights underscore DF dot show. Now we can use the select asterisk from NYC underscore flights to get the same output. Now suppose we want to look at the minimum airtime of any flights. We use the select minimum airtime from NYC flights, that is the SQL query. We pass all the SQL query in the SQL context.SQL function. So as you can see here, we have the minimum airtime as 20. Now to have a look at the records in which the airtime is minimum 20. Now we can also use nested SQL queries. Now suppose if I want to check which all flights have the minimum airtime as 20. Now that cannot be done in a simple SQL query. We need nested query for that one. So selecting asterisk from New York flights where the airtime is in, and inside that we have another query which is select minimum airtime from NYC flights. Let's see if this works or not. So yes, as you can see here, we have two flights which have the minimum airtime as 20. So guys, this is it for data frames. So let's get back to our presentation and have a look at the list which we were following. We completed data frames. Next we have storage levels. Now storage level in PySpark is a class which helps in deciding how the RDDs should be stored. Now based on this, RDDs are either stored in disk or in memory or in both. The class storage level also decides whether the RDDs should be serialized or replicate its partition. Now the final and the last topic for the today's list is the MLlib. Now MLlib is the machine learning API which is provided by Spark, which is also present in Python. And this library is heavily used in Python for machine learning as well as real-time streaming analytics. Now various algorithms supported by these libraries are, first of all, we have the spark.mllib. Now recently this PySpark MLlib supports model-based collaborative filtering by a small set of latent factors, and here all the users and the products are described, which we can use to predict the missing entries. However, to learn these latent factors, spark.mllib uses the alternating least square, which is the ALS algorithm. Next, we have the MLlib.clustering, and a supervised learning problem is clustering. Now here we try to group subsets of entities with one another on the basis of some notion of similarity. Next, we have the frequent pattern matching, which is the FPM. Now, frequent pattern matching is mining frequent items, item sets, subsequences, or other substructures that are usually among the first steps to analyze a large-scale data set. This has been an active research topic in data mining for years. We have the linear algebra. Now, this algorithm supports PySpark MLlib utilities for linear algebra. We have collaborative filtering. We have classification. For binary classification, various methods are available in spark.mllib packets such as multi-class classification, as well as regression analysis. In classification, some of the most popular algorithms used are naive Bayes, random forest, decision tree, and so much. And finally, we have the linear regression. Now, basically, linear regression comes from the family of regression algorithms. To find relationships and dependencies between variables is the main goal of regression. Although PySpark MLlib package also covers other algorithm classes and functions, Let's now try to implement all the concepts which we have learned in PySpark tutorial session. Now here we are going to use a heart disease prediction model, and we are going to predict it using the decision tree with the help of classification as well as regression. Now these all are part of the MLlib library here. Let's see how we can perform these types of functions and queries. So first of all, what we need to do is initialize the Spark context. So next we are going to read the UCI dataset of the heart disease prediction, and we are going to clean the data. So let's import the pandas and the NumPy library here. Now let's create a data frame as heart disease DF, and as mentioned earlier, we are going to use the read CSV method here. And here we don't have a header, so we have provided header as none. Now the original dataset contains 303 rows and 14 columns. Now the categories of diagnosis of heart disease that we are predicting, if the value 0 is for 50% less than narrowing, and for the value 1 which we are giving is for the values which have 50% more diameter of narrowing. So here we are using the NumPy library. Now these are particularly old methods which is showing the deprecated warning, but no issues, it will work fine. So as you can see here, we have the categories of diagnosis of heart disease that we are predicting. The value 0 is for less than 50 and value 1 is greater than 50. So what we did here was clear the row which have the question mark or which have the empty spaces. Now to get a look at the data set here, now you can see here we have 0 at many places instead of the question mark which we had earlier. And now we are saving it to a txt file. And you can see here after dropping the rows with any empty values, we have 297 rows and 14 columns. Now this is what the new clear dataset looks like. Now we are importing the MLlib library and the regression here. Now here what we are going to do is create a label point, which is a local vector associated with a label or a response. So for that we need to import the MLlib.regression. So for that we are taking the text file which we just created now without the missing values. Now next what we are going to do is pass the MLlib data line by line into the MLlib label point object, and we are going to convert the -1 labels to the 0. Now let's have a look after passing the number of training lines. Okay, we have the label point 0, 1. That's cool. Now next what we are going to do is perform classification using the decision tree. So for that we need to import the PySpark.mllib.tree. Now next what we have to do is split the data into the training and testing data, and we split here the data into 70s to 30s, which is a standard ratio, 70 being the training data set and the 30% being the testing data set. Now next what we do is that we train the model which we have created here using the training set. We have created a training model, decision tree.train classifier. We have used the training data, number of classes is file, the categorical feature which we have given. Maximum depth to which we are classifying it is 3. Next what we are going to do is evaluate the model based on the test data set now and evaluate the error. So here we are creating predictions, and we are using the test data to get the predictions through the model which we created here. And we are also going to find the test errors here. So as you can see here, the test error is 0.2297. We have created a classification decision tree model in which the feature less than 12 is 3, the value if the feature is less than 0 is 54. So as you can see, our model is pretty good. So now next we'll use regression for the same purposes. So let's perform the regression using decision tree. So as you can see, we have the trained model and we are using the decision tree.train regressor using the training data, the same which we created using the decision tree model up there. We use the classification. Now we are using regression. Now similarly, we are going to evaluate our model using our test data set and find the test errors, which is the mean squared error here for regression. So let's have a look at the mean square error here. The mean square error is 0.168. That is good. Now finally, if we have a look at the learned regression tree model, so you can see we have created the regression tree model till a depth of 3 with 15 nodes. And here we have all the features and classification of the tree. So guys, that's it for today in the session. I hope you enjoyed this session and learned lots about PySpark, the RDDs, frameworks, Spark contexts, MLlib, the broadcasts and accumulators, and so much more. Thank you for listening.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!